You're welcome once again to my YouTube channel, Achievers Consult, where science is made easy. We'll be continuing from where we stop under reactions of alkanals, chemical properties of alkanals. We've looked at oxidation reaction. We said when alkanals are oxidized, they become carboxylic acid. If ethanol is oxidized, it becomes ethanoic acid. If propanol is oxidized, it becomes propanoic acid. So today we want to look at reduction reaction. They don't only undergo oxidation reaction, they also undergo reduction reaction. Ethanol is easily reduced to ethanol through the addition of hydrogen to the carbonyl bond. So the hydrogen can be generated by using strong reducing agents such as lithium tetrahydroaluminate 3, sodium tetrahydroborate 3, sodium tetrahydroborate 3, then sodium amalgam and water. These are examples of reducing agents. Lithium tetrahydroaluminate 3, sodium tetrahydroborate 3, sodium amalgam and water. All these are examples of reducing agents. They contribute hydrogen with which the alkanal is reduced to alkanol. In oxidation, alkanals are oxidized to carboxylic acid. That means ethanol becomes ethanoic acid, methanol becomes methanoic acid, propanol becomes propanoic acid. But when it comes to reduction, they are reduced from alkanal to alkanols. That means ethanol becomes ethanol, propanol becomes propanol when they undergo reduction. You know, reduction is opposite of oxidation. Oxidation is addition of oxygen, while reduction is removal of what? An addition of hydrogen. Now, let's look at this equation, sodium amalgam and water. This is sodium amalgam. When sodium reacts with mercury, sodium amalgam plus water, giving us sodium hydroxide plus mercury plus hydrogen gas. Then nascent hydrogen produced by reaction between zinc and a dilute acid or catalytic hydrogenation. Now this is an equation of an alkanal. This is ethanol plus hydrogen. This hydrogen is from the reducing agents. This hydrogen comes from the reducing, any of these reducing agents, giving us ethane plus water. Now let's look at addition reaction. Apart from oxidation reaction, reduction reaction, they also undergo, alkanals also undergo addition reaction. It undergoes addition reaction with the molecules of the type H to S, e.g., that means from water. They undergo addition reaction with water, making use of this hydrogen. Then addition reaction with hydrogen cyanide, addition reaction with HOR, where R is an alkyl group, addition reaction with ammonia. Now let's look at with water, this first one. With water, an equilibrium mixture of ethanol and ethane 1,1-diol is formed. When ethanol reacts with water, it results to ethane 1,1-diol by the addition of hydrogen from this water. This writer, it has hydrogen from water. It has hydrogen. It extracts the hydrogen, then the hydroxy group is this hydroxy group we have here. This hydroxy group removes one hydrogen and replaces the hydrogen. Then with hydrogen cyanide, we are looking at the next one now. Addition reaction with hydrogen cyanide. Hydrogen cyanide adds to carbonyl carbon, forming hydroxynitride known as ethanol cyanohydrin. So this an alkanal, ethanol plus hydrogen cyanide, giving us CH3CHOCN. This ethanol cyanohydrine. This compound is called ethanol cyanohydrine. Then reaction with ethanol, addition reaction with ethanol. In the presence of hydrogen chloride or anhydrous calcium chloride, ethanol forms an addition compound with ethanol known as hemiacetal. Now this is ethanol. This is ethanol. This is alkanal functional group. This is ethanol plus hydrogen plus ethanol plus this ethanol giving us hemiacetal. This is the compound known as hemiacetal. This ethanol reacting with alkanal, giving us a compound known as hemiacetal. Then with ammonia, addition reaction with ammonia, it forms an addition compound with ammonia known as hydroxyamine. This ethanol plus ammonia, NH3 is NH2 because the one hydrogen is detached. You know, we showed you how it goes. It gives hydrogen to this side, then the other one goes to the other compound. So giving us this compound CH3CHO attached with amine. So this hydroxyamine, this compound is known as hydroxyamine. Hydroxyamine. Then in addition to addition reaction, oxidation reaction, reduction reaction, addition reaction, alkanals also undergo halogenation. You know what is halogenation? When they react with halogens, chlorine, fluorine, bromine, iodine, astatine. Then iodoform reaction. Also undergo iodoform reaction. That means it can react with phosphorus iodide. So you read up these two, halogenation and iodoform reaction. So we'll continue from here. We are going to look at uses of alkanal in our next lesson. We'll start from there. Look at the uses of alkanal. One of the use, a major use of the alkanal is for embalmers. When you go to the morgue or you go to the mortuary, the liquid they use in cleaning corpse, embalming corpse, is methanol, known as formalin or formaldehyde. Formaldehyde. It is used in embalmers. It is used in the hospital, in the morgue, in the mortuary for embalming corpse. It is used for preservation of anatomical specimen. Any anatomical, even in the biology laboratory, we use it to preserve specimen. So a major function is the use of formaldehyde for corpse preservation, for the preservation of cadavers. So see you next class.